Hello there on YouTube. My name is Logan. My role here at Manhattan Prep is a GRE instructor, as you would expect, because this is going to be a GRE free prep hour. Hello as well to those of you joining live. If you've never been to a free prep hour before, we do these a couple times a month. They are, just like they sound, hour-long lessons that are free. We do them here on Zoom for people attending live. And we put them all up on YouTube after the fact. So if you've never gone to our playlist, go ahead to our free prep hour playlist on YouTube, and you're going to find lots and lots and lots of lessons about pretty much every topic on the GRE. And the topic we're going to do tonight is percent change. Now, we have a few lessons up in our series about percents in general, and including one that was just done a couple months ago by one of my colleagues, Jerry. But what we're going to do tonight is specifically percent change, which is kind of a subtype of percentage questions. So let's get started by just making sure we understand the difference between what I mean by like a regular percent question and a percent change, or more formally, I would say a percent of question and a percent change question. So I'm gonna just write out a couple examples here of like how questions or phrases might be phrased in each of these two types. I'm gonna imagine I'm a farmer and I have cows. Okay, what if I said on the left, I might say, I started this year with a lot of cows. Now I only have 75% of the cows I started with. Okay. You notice the literal use of the word of, 75% of the cows that I started with. I could say the same exact fact, but say it in a percent change way like this. I started this year with a lot of cows. Now I have 25% less cows than I started with. And you can see the difference here. The word coming right after the percentage is less. And when you see a word like less than, greater than, stuff like that, you're very likely dealing with a percent change question, and the math behind it is a little different. One other set of examples. My neighbor also has cows. I have 150% as many cows as they do. 150% as many. So I'm comparing the amount of cows I have versus my neighbor. I could express the same concept over here in a percent change way. My neighbor also has cows. I have 50% more cows than them. Probably makes sense that these ones on the left are percent of and the ones on the right are percent change, but it can actually be surprisingly tricky sometimes to figure out which one the GRE is dealing with on a certain question. And if you're ever not sure, two things are, the first thing is look for the language. A percent of question will have, it'll use of or as many. Like it'll usually be, this is something percent of something else, or this is something percent as many as something else. And then a percent change question will pretty much have to have a change word like less or more. And really what you're doing in percent of is here, you're comparing two numbers, or I'll say two values, two real world values. Here, you're comparing one real world value to a certain amount of change or a certain difference. And you know, we see this sort of stuff out in the news all the time, talking about percentages of things going up and down or being certain percentage of something else. So probably these topics will feel familiar, but it can help to get into really understanding behind the scenes, what's the difference? Comparing two real world values, comparing a value to a certain amount of change. And by the way, the typical scenarios in which you'll see percent change will be one of these two scenarios that I put up here. Here is a change over time. That's one type of percent change you see a lot. And here is comparing, like, basically who has more. Do I have more, or does someone else have more? Or does team A have more, or team B have more? Something like that. The reason I decided to do this lesson, even though we've done a couple of percents in general lessons that covered percent change a little bit, is that I actually took the GRE last week. All of us teachers here at Manhattan Prep, we retake the tests that we teach every 2 or 3 years, so that we keep a strong intel of what's happening on the real test. And one of the quant topics that I noticed was really tested a lot was percent change specifically. I saw a whole lot of questions that were phrased similar to these. And I saw more of these than of these. Now, take that with a certain amount, a certain grain of salt, because exactly what I saw isn't exactly what you're going to see when you go take the GRE. But it was significant enough that I thought, oh man, maybe we should be emphasizing percent change a little more compared to percent of in some of our materials. I would say I probably use this process like 6 or 7 times on the test, which would make it like one of the most used math topics, actually, up there with things like solving algebra equations. So let's talk about how we actually do the math here. And the structure of tonight is going to be, I'm going to show you a couple of the ways that you're commonly going to calculate percent change. And then we're going to try a few full-on GRE-like problems. And at that point, I'll ask y'all who are here. Happy to see all of y'all who are here. I'll ask you to try them yourselves, and we'll see how that goes. Okay. This slide, if any of you are GRE Free Prep Hour super fans, you saw my colleague Jerry teach exactly this slide a couple months ago. But I'm going to run through it real quick because this is going to show us importantly kind of the formulaic, yeah, that's the real word, the formulaic way of solving percent change. And it reads like this. Percent change, actually here, I'll type it out, that'll be a little better. Percent change divided by 100 is equal to change over original. Let me draw in my fraction lines here. Percent change divided by 100 is equal to the change itself over original. And let me get a little more specific about the change itself. You can mathematically express this by saying new minus original. So new is whatever you have now. Original is what you started with. And that is how you get your percent change formula in kind of like a fraction form. It's really helpful to know this formula. As we're going to see in a little bit, you don't always need to go to this full-on formula when you're solving a percent change problem, but it's a good place to start. And when you're on a difficult percent change problem, it's a good sort of backbone to fall back on, because this is always true. This statement here is always true about the percent change in any situation. To show how it would play out in this situation, on Monday, a stock costs 20. On Friday, the price increased to 120. So in this case, it's pretty easy to tell what's the new and what's the original. The original is whatever came first in time. This is one of those changes over time examples. And the new is whatever we have now. So I would do my new is 120. My original was 20, so I'll do 100 minus 20 divided by the original, which was 20. That's going to equal my percent change over 100. Over here on the right, I get 100 over 20, or just 5. And over here on the left, I still have percent change over 100. And if I multiply both sides by 100 to kind of eliminate that fraction on the left, pardon my handwriting here, y'all, then we're going to get that the percent change is 500% increase. 500% increase. It's common that people look at this and they think 600%. For a lot of percentages, we look at it and we think, what's, blank divided by blank, and we just divide the two numbers we see. And that would work if it was percent of, if it was that other kind of more basic type of percentage question. If they phrased it as, I'm going to write it in sort of small text over here. The price, the price on Friday is what percentage of the price on Monday? The answer would be 600%. You would just take the Friday price, divide it by the Monday price, and you would have the Friday price is 600% of the Monday price. That actually goes along perfectly with the fact that it's a 500% increase. And just take note of the fact that we have this like 100% differential between the percent increase and the percent of. One way you can think of that is originally it's 100% of itself. Everything is always 100% of itself. So if you increase 100% of yourself by 500%, 100% plus 500% increase, 600% of your original. So it's no coincidence that we have a 100% separation there. And just notice the difference in phrasing here. Percentage of, percentage increase. The wording really tells you which type you are dealing with. Let's look at the second situation here. And we have the same two numbers, 120 and 20. So at first we might think it's going to be the same percent change, but it's not. Here, again, we're going to be looking for percent change over 100 equals new minus original over original. Which one's the new and which one is the original? Well, the original is going to be 120. How do I know that? It's right here, less than the price of stock A. Really good tip is that whatever they say less than or greater than, whatever that thing is that you're comparing to, it means that A is the original. You can call it the original in this situation. It's the starting point that we are comparing to. So even though this is not a change over time, this is the other type of just comparing to things and saying which is what percentage greater. We can still figure out the original by saying what are we less than. So our new is 20 and our original, we're comparing the 20 to 120. What percentage is it less than 120? So 120 goes there on the bottom. This time we get negative 100 over 120 equals the percent change over 100. I would recommend putting that in your calculator. You're going to get, if I move the 100 over here, basically negative 5/6. This is my reduction of this times 100. 5/6 is about 83.3 in decimal form. So it's 83.3% is the percent change. So a couple things to note from this problem. The negative sign here, actually, it doesn't really matter that much. This is one case where you don't need to worry about positive or negative a huge amount because it's already basically baked in with like the phrase percent less or percent greater than. If it's percent less, you still put in a positive number and it means that much less. And if it's a multiple choice regarding percent change, they're going to be all positive numbers. That's okay, because if it's a percentage going down, they already said percent less. So it's okay to put in a positive number that's going down by that amount. And then also this key thing here of being less than A, that's how we knew that A was the original that we could put on the bottom. Okay, so this has been a couple examples of how to use this formulaic way of basically dropping in our information into the new and the original to figure out the percent change. But there's a shortcut that you can use not every time, but pretty often. And that's what I'm going to show you next. And then we'll get into some real GRE problems or real GRE-like problems. Give this a quick read. So the question at hand is, we have a 10% discount and a 10% tax. So these are both percent changes. We get a certain amount of like the raw total of our grocery bill. It's going to go up a certain percentage and it's going to go down a certain percentage. When you know the percent change and you know the starting point, you can use a nice shortcut with multiplying by decimals. Let's talk about how that works in general, and then I will come back to this specific question. So I'm going to cover up the question briefly, and then we'll come back and see how this plays out. If I give you a phrase like X increased by 17%, how do we find the new X? The fastest way to do that, take X, multiply it by 1.17. Where is that 1.17 coming from? The 1, if you multiply X by 1, it just stays the same, right? So the 1 part itself is just the 100% you started with. The 0.17 is the most efficient way to add the extra 0.1 or the extra 17%. The extra 17%. So just taking your starting point and multiplying it by a decimal conversion of the percentage is a really, really good move. For example, if I said X increased by 85%, then suddenly instead of 1.17, I have 1.85. If let's say I went up by a huge amount, X increased by 205%. Or really, let me actually start with 105. This is where it gets like a little trickier we still start with the 100%, and then we have to add a 1.05. So in this situation, you would put in a 2.05 here. So this is a nice shortcut, but if you ever get confused trying to use the shortcut, that's where you can go back to that formula that I showed on the last slide as a way to sort of bail you out. Let's talk about a decrease though. X decreased by 10%, or I'll do 15%. How do we find the new X? We're going to need a little bit of a different process here. Well, if you decrease by 15%, what do you have now? Now you have 85% of what you started with. You can see how percent of and percent change very intimately connected. And I can express this idea and this idea, same idea, by taking X and multiplying it times 0.85. What is that? Well, I started, it's basically here, like I took 1 minus 0.15. And then I just simplified it. The 1, again, representing the starting point, and the subtraction of 0.15 representing the 15% less. If I were to basically simplify this by combining this subtraction, I would get to this right there. So a really good decimal calculation shortcut for when you know the percent change and you know the starting point is when I would most recommend using this shortcut. Let's go back to this question, and we're going to find a slightly surprising answer here. And I'm going to find my answer by starting by imagining a $100 grocery bill. And quick note, 100 is just a great number to try on percentages always. If you are just beginning your GRE studies, something you're going to hear a lot as you study is that it's a good idea to just pick numbers and see what happens in a lot of different types of GRE problems. Percentages is one of those types very often, and 100 is a great number to start with because it just makes calculating your percentages pretty easy. Let's see what happens when we do the tax first. Well, I'm going to multiply times 1.1, my starting point, because I have a 10% increase. You'll find if you do that, that I have $110. So that's my plus 10%. And then if I do my discount after the fact, where I'm subtracting 10%, what's a good way to subtract 10% is to multiply times 0.9, because I now have 90% of what I started with. And if you put in your calculator 110 times 0.9, you're going to get $99. Okay, so we saved $1 overall. Let's try the discount first. If we multiply times 0.9, I have a $90 bill after my discount. But then my tax, I'm going to multiply times 1.1 again, and I'm going to get back to 99. So interestingly, it didn't matter what order I went. So the fact that you went from 100 to 99, that's not super important. Whether you went up or down would depend a little bit on what exact percentages you had. But if you're applying any discount and any tax in this way, it actually doesn't matter what order you wind up going. And the only reason why that's interesting is it kind of shows us how these multiplications are working behind the scenes. In this one over here on the left, we did $100 times 1.1 and then times 0.9, up 10%, down 10%. And over here on the right, we took the $100 starting point times 0.9 times 1.1. The same three things multiplied. If you're ever multiplying and all you're doing is multiplying, the order in which you multiply the stuff makes no difference. That's why behind the scenes mathematically it comes out the same. So this is an example of something we sometimes call successive percents, where they basically ask you to do a percent change and then do another percent change on top of that. And that's a little bit of a subtype that within percent change that the GRE likes to do to see if you can do this quick decimal shortcut. Because if you don't, it's still possible to do it without this decimal multiplication shortcut, but it'll just take a while. And this also tests that you understand that we didn't just go, at first glance, a lot of people think up 10%, down 10%. So it must be equal. No. And the reason why not is because you always have to keep in account, well, 10% of what? 10% of what? What are we taking the percentage of when we add or subtract? And if that's changing as you go along, which it is, then the 10% up and the 10% down may not be exactly the same thing. Very important to understand that. So let me check the chat settings here. I think that yes, attendees can chat with everyone. So if y'all have any questions about what I've done so far, feel free to put them in the chat. I should be able to see those. There's also a Q&A feature. I believe what that will do is allow only me to see it. No one else who's in here will see it. So send me something in the Q&A button or through the chat button if you have any questions. But we're going to move on to some real GRE problems. After just sort of crystallizing what I've pointed out so far, my advice as you're getting better at these is use the decimal multiplication shortcut if you know the starting point and you know the percent change. If you don't, and particularly if you're trying to find the percent change, use the formula is how I would generally recommend it. Percent change over 100 equals change over original. So that's kind of my quick and dirty of when to use each of the two strategies that we've looked at so far. Okay, I got 4 questions lined up here. Hopefully we can get through all 4. And all of these are from our GRE 5-pound book, but they are based on real GRE questions. All of these, I think, are pretty accurate to real GRE questions you could see. And like I mentioned, I saw a lot of these last week in the real GRE. Okay, take 1 or 2 minutes and put in the chat your predicted answer once you get one. I see a couple answers coming in. Thanks for that. Take another 30 seconds or so. There's a few ways of doing this. I'm going to try to walk through a couple of them. And every one I'm showing you does have a little bit of a twist on the information that I've shown so far. I didn't want to make it too easy. If you're stuck, I would say try going back to that formula version and plugging in what you know. Thank you, Anna. Thank you, Namratha, for the answers coming in. If you're stuck, I'm also curious, you can put in the chat or the Q&A, what's tough about this one? What's tough about this one? Okay. I'm going to get started here, and I'm going to go through a couple different modes. If you've been working on it but not sure your answer, I'd love to hear a guess in the chat, just so I know where y'all are at. I'm going to try to label for each of these, like, what is one of the twists? And here I've put the formula up here, but before we get into this, I'd say a twist of sorts on this problem is they gave us the new, but not the original. A percentage change is usually a little more intuitive when they give us the starting point. You know, that was one of my points on the last slide, is if you know the starting point and you know the percentage, then you can just do this really nice shortcut with the decimal multiplier. But it's a little more annoying, to be honest, when they give you the new price. 612 is the price after the discount. So what are we supposed to do with this? Let's try something that I recommend, and the reason why I like this as like something to fall back on. Let's try just drag and drop the information we know into this formula. 15% discount means that, here I'll use a different color, 15% discount means that 15 is the percentage change for this problem. 612 is the price now after the discount. So that is the new price. So I can rewrite this as 15 over 100 equals 612 minus the original over the original. This is pretty yucky, but it is still solvable. It's still totally solvable. If you're ever in this situation where you don't know the original and you're trying to solve it with the formula, try to get rid of the fractions by cross multiplying, by which I mean we'll multiply both sides by this to bring this over there, and we'll multiply both sides by 100 to bring 100 up there. And what we get is 15 times, I'm going to change the word original to a variable x. So I'll say x is my original, because I just don't like having full-on words in my equations. And then over here, I have 100 times 612 minus x. 15x equals 61200. Remember, when you multiply by 100, you can always just take those two zeros and pop them onto the end there. So 61,200 minus 100x. 115x is that big old number there. And I would certainly be going to my calculator. You do have a calculator on the GRE. And 61,200 divided by 115 is 532. So I think I messed something up. What did I mess up here? Oh, I divided by 115. I'm supposed to divide by 15. Oh no, it is 115. Where have I gone wrong? Percent change equals new minus original over original. If you spot my error, let me know in the chat. So I change this to x divided by x. I'm not sure where I've gone wrong, to be honest, but I know that I'm getting a number that it does not match any of the answers. And I'll tell you what I do in the real world when that happens is sometimes I'll retry with like a different sort of algebra shortcut. So I'm gonna, instead of doing this cross multiplication mode, I'm gonna reverse course, come back here. And let's try turning, no, one suggestion in the chat is the denominator supposed to be the new? No, the denominator is always the original. It's definitely always the starting point in the bottom. Let's see, 0.15, I'm gonna try a decimal thing over there, equals 612 minus x over x. So 0.15 x equals 612 minus x. 1 point. Oh, you know what I think it is? I think I slightly lied to y'all earlier, and that this should have been a negative. Let's come back and let's see what happens when we make that a negative here. Yes, there we go. This is going to work out correctly. If we have a negative 15% change, then this is going to correctly show negative 0.15. When I do my process, it's going to show negative 0.15x. When I add my x to both sides, I'll get 0.85x. And then when I do 612 divided by 0.85 as like my final algebra step, then this is going to give me there it is. The answer that many of y'all submitted, which is the correct answer, $720. So let me correct something that I said earlier when I misspoke. When you're substituting earlier, I basically said you don't need to worry about positive and negatives with percent change. As this example just showed, if you're dropping in the percent change to the formula, you do need to put a negative if it is a percent decrease. I apologize. Go back and cross that out on your notes if you wrote that down. And believe me, where you don't need to worry as much about the negative is like on a multiple choice. And if they say what percentage decrease did this have, they're still going to put a positive percentage in there, because once you just sort of summarize, saying in a summary way, this had a 15% decrease. You don't need to say it was a negative 15% decrease. Okay, my apologies. With that correction and the negative percentage in here, we can see how dropping all of our information in led us to 720 as the correct number. A couple things I want to point out. One thing that sometimes people do here is they say, okay, if 15% less got us to 612, let's take 612 and add 15%. And I know how to do that. I know that that is 612 times 1.15. Well, if you do that, you're going to get betrayed, because it's going to lead you to $703.80. So I think a couple people submitted C, and what you did is you added 15% to 612. And yes, that is not quite the same as figuring out what is 612 15% less than. Basically, 15% on top of 612, well, we're taking 612 of, or we're taking 50% of 612, so it's a smaller number, relative to subtracting 15% from 720. 720 itself is larger, so that 50% is going to be a larger amount. Quick shout out, if any of y'all did it a slightly different way, you might have skipped all this mess if you kind of had that intuition and you thought 15% less. Well, that's the same as 85% of. So I'll draw a little box to separate this in the corner here. But this question could just as easily have been phrased as 612 is 85% of what number? And from that, if you're good with percent of stuff, you might be able to say, okay, 612 is, there's my equal sign, 85% of X. 612 is 85% of what number? And take a looky here. That is the same thing we had in exactly this step. So whether you plug into the percent change formula and process through, versus whether you kind of change it to a percent of problem so that you can write it out in a different way. If you do it right, it's going to be mathematically equivalent, as we see right here. Okay, let's move on to the next one. It should go a little faster because I won't make that same positive negative sign flub. This next one, I'll just go ahead and tell you all right off the bat. The twist in this one is just that you have to do the process several times. Twist. This one has many percent change steps. So you got to keep your math sharp for each step. Try it out. We'll talk about it in about 2 minutes. Take another 30 seconds or so. I was just pulling up a slightly different problem I'm going to show next than I had planned. Tell me in the chat, do you got an answer? Are you stuck? If so, where are you stuck? Thanks, Princey, for the answer there. For anyone who is stuck, one quick hint before we start. I would advise to take it in pieces. Figure out this number first, then figure out this number, and then try to combine them. Thanks, Namratha, for the answer there. Thanks, Anna. Oh, they're pouring in. And so far, it's a very popular vote for E. Let's see if that works out. The number that is 50% greater than 60. Well, this is a perfect example of earlier when we talked about we know the starting point, we know the percent change. So I can just do my decimal multiplication process. 90 is the number that's 50% greater than 60. Same thing here, 20% less than 150. I can do my multiplication process with the decimal, just remembering to subtract the 0.2 here. And in this one, I'm going to get 120. And then once I reach this point, I just have to be careful about what's my original and what's my new. Well, remember, less than the blank. When you see than the blank, whatever goes there, whether it's greater than or less than, is your original in the formula. So the percent change is going to be my original is 120. My change is 30. So 30 over 120. Y'all got it. That's 1/4. And 1/4 is 25%. Yay for all of the correct answers in answer choice E. Okay, I had a Q&A question to try another full question of that kind of successive percents category. So I have a question I just pulled from our 5-Found book. And here it is. So freshly copied that it's in the screenshot tool already. Try it and send me your vote in a moment or so. And if you haven't seen this question type before, this is called a QC question. There are a lot of these on the test, 7 or 8 per section or per set of 20 math questions. Here's the answer options. A means quantity A is greater. B, quantity B is greater. C means the quantities are equal. And D means not enough information to determine which is greater. Always the same answer options on this style of question. That's why we didn't have them written in the book. But give this one a shot. Let me know in the chat, A, B, C, or D, once you get a chance to try this one. If you're stuck, my hint is to try $100 as the starting point, like we did earlier. And I'll talk in just another 20, 30 seconds or so. Keep those answers coming. Okay, just gave myself a little more drawing room here. The answers are pouring in once again for answer choice A. Let's test it out. I'm going to try 100 on both sides. And by the way, y'all, when I have to do work in A and B, I don't always do A first. I start with whatever side's easier, and quantity B is certainly easier. 50% off. Discount, I'm going to multiply it times 0.5 because the price is going to be half of what it was before. So $50 would be my price. Over here, I have to take 10% off 5 times, and I have to do it with the decimal multiplication. Well, I could do it with the longer formula way if I wanted, but I cannot. I can't do this. I can't say 100% minus 10% minus 10% minus 10% minus 10% minus 10% minus 50%. It's very tempting to say the minus 50% is the same because it's 5 minus 10%. So why wouldn't it be minus 50%? Tell me in the chat, can anyone put in their own words? Why is this not right? Why is subtracting 10% 5 times not the same as subtracting 50%? In the meantime, I'll write out how my calculation would happen here. I'll type it. I would have 100. Multiply it times 0.95 times like this. What I got when I did that was $59 and 5 cents, which is larger than $50. So y'all are correct. It is that quantity A is greater. And I like that phrasing, Anna, in the chat. Each time we take 10% off, it's 10% off of a new number. So we have to incorporate that in our process. Luckily for us, the multiplication method automatically does that for us, basically. Just by subtracting percents, no. So be very careful. In percent change is weird as it seems. You can't literally just add up the percent changes or subtract up the percent changes to find the total percent change. You got to either go through the formula or go through this multiplication shortcut. Okay, there's only a couple more minutes before technically our hour is up, but there's one more question I want to show y'all. So anyone who wants to stay, go for it. I got a question in there. How did I find the 0.9? Where did the 0.9 come from? 10% discount. If I have 10% less equals 90% of the starting point. So same as earlier when I multiplied, if I said increase by 17%, let's multiply times 1.17. Take that starting point of 1, up 17%. 9.9, well, that's like saying that I have 10% less of where I started. Take my 1, where I started, subtract the 0.1. Princey, looks like that makes sense based on what you wrote in the chat. Glad that that could clear it up. Okay, let's, I do want to show you all this one more problem. Because another thing that they kind of like to do is sometimes to put variables inside of percents and percent change, and that can be pretty tricky. So you should be seeing a problem about Greta's salary and Annika's salary. Try this out. You may need to try a couple different numbers, see what happens. And we'll talk about this one. We'll go a few minutes past 9 Eastern, and then we'll call it a night. Oh, I'm so sorry. I should have had the answer choice options up here. I'll type them out again right here. So I'm going to start into this. I know y'all are probably still working on it. I wanted to show y'all just because the phrase X% can be spooky. But if you take it literally, it helps. X%, X over 100. Y%, Y over 100. So in general, if you see X% or Y% in the future, just take that variable and put it over 100. I can't quite say that's all you got to do because usually there's like more problem beyond that, but that's how you start. X% is X over 100. Now, on the other hand, this question actually comes down to a key strategy. Oh, I'm pausing. My screen share is paused. You can't see my writing. There it is. This question itself is best tested by picking numbers. So I don't have time to really get into a full-on lesson of all the strategies of picking numbers on QC questions, but if you're near the beginning of your studies, get used to picking numbers in these quantitative comparison questions. And as a general rule of thumb, pick really easy numbers to start with because they're going to teach you the most in the least effort. So I'm going to pick numbers that are not very friendly to these characters. I'm going to imagine that Greta's salary was $1,000 per year. Okay, and that the percent change, and that Y was 10, a 10% raise. Now, what that means is Annika's situation is the opposite. Y had a $10,000 salary. I have to keep the Y the same in the two situations, and a 1% raise. So let's try this out. 1,000 was Greta's initial salary. A 10% raise, if I times by 1.1, that's going to give me my 10% raise, right? 1,100 would be what I get there. So, okay, I got a $100 increase. Let's test the other side. I have a $10,000 salary times 1.01. That's my 1% increase. And if you got to go to the calculator for that, that's all right. I'm going to do it right now just to check my work. But I got 10,100. Also a $100 increase. Weird. Let's try that again. Let's see what happens if I pick like slightly different numbers. Because so far I found that they're equal, but usually you want to try like a few different things and see if they keep being equal. So I'm gonna try another simple scenario. What if it was $2,000 for Greta and a 5% raise? And that would mean it was $5,000 for Annika and a 2% raise. 2,000 times 1.05. That's going to lead to 2,100, a $100 increase. Oh, I accidentally have made a situation where we keep getting a $100 increase. It wouldn't always be a $100 increase. That's just what we have right here. And the same thing actually is going to happen over here. I'm going to get a $5,000 starting point times 1.02. 5,100 would be what I get from this if you bring that to your calculator. Again, I have a $100 increase. Why does this keep happening? Why surprisingly is the answer C? I'll show you. If we were to write this out in kind of a more formulaic way, the dollar amount of Greta's raise. Got a good question in the chat. Why is Annika's salary greater than Greta's? I'm undoing all my erasing here. I'd say the short way to say that is because it's X and X, Y and Y. I have to pick the same X for these two numbers and the same Y for these two numbers. And I just happen to have decided when I was randomly picking numbers to give Greta a higher salary and a lower percent raise. Oh, sorry, Greta a lower salary, 2, and a higher percent raise, 5. Annika the higher salary, 5, and a lower percent raise, 2. But I could have easily reversed that. So just basically a coincidence of what numbers I picked. If you pick different numbers for X and Y, then you might have come out with Annika having a lower salary. I'll try to show quickly why we keep getting the same thing on both sides. On Greta's side, what we're doing is taking Greta's original times 1 plus Y over 100, right? A Y% raise would be 1 for the starting point plus Y over 100. Over here, we're taking Annika's original times her starting point plus X over 100. That's her X% raise right there. Well, what happens when we substitute in those originals? The original for Greta was the X. The original for the Annika character was the Y. And what happens when I multiply this out? Here I get X plus XY over 100. If I multiply this through. Here I get Y plus YX over 100. If I multiply this through. Now, these things are not necessarily the same, but what are they asking? They're asking for the increase. Like, how much was the raise itself? And that is just these two things. X times Y over 100, Y times X over 100. Same result. That process I just went through is not what you have to do to solve. Trying out numbers, seeing what happens, and seeing that you keep getting the same increase on both sides is a very reliable, great way to solve this problem. I just wanted to show if you were like, huh, how could it be? How could it be that the dollar amounts are actually the same? It's because in either case, when we actually get in here, drop in our X's and Y's, put in our Y over 100 for Y% and X%, like I was talking about, we actually get the same output for the amount increase. Well, that has been percent change. It's a tough variant on percentages in general, but it's a really good one to prepare for. Like I said, I think you can expect to see several questions of percent change type on the test. Now, I don't mean you're going to see several ones like this one that I have here on the screen. It's always a pretty hard one once they start putting variables into percentages like this. What I think you can expect to see several of is if I go back to the ones like this, where you got to figure out a starting point after they give you a percent change. The ones like this, where you just got to do percent change over and over. And the ones like this, where they just give you the input and they say, how much did it increase? If you can handle these on the screen, and if you are handling these that we got here, you are all set for percent change. And ones like this are more of challenge mode. Always good to get to challenge mode, but it's fair to have to build up to it as well. All right, thanks y'all. If you have any remaining questions about the one I just showed or anything else, I can stick around for just another moment or two, but that's the end of my presentation for the night. Thanks for staying here for learning about percent change. Go check out the series. It's a great series on our YouTube channel with lots and lots of topics covered. And thanks for being here on a Monday night. See y'all next time.